All right, so we're going to tell you what is a ray diagram. So imagine you have a light, and from this light bulb, light is traveling out in waves in three-dimensional space. So there are my light waves traveling out around the light bulb into three-dimensional space. And over here is my eye. That's my eye. And I'm receiving that light into my eye, and I see the light bulb, and I see the light from the light bulb. But this is difficult to draw. So a ray is just an arrow that shows the direction of the wave fronts. These are called the wave fronts of the light. And as long as you make it perpendicular to the wavefront, you can see right here, those are right angles to those wavefronts. And so that means I can draw rays in all these directions. And that would show me the direction that the light is traveling. The light is impingent, or the light shines upon everything around here. But I only care about the light that comes to my eye. So why do I need to draw all this other stuff? I'm just going to draw the part of the wave that's coming to my eye. So a simplified drawing then for this would be, here's my light bulb, and here's my eye, and all I care about is the light coming to my eye from the light. So this would be a much simpler diagram to draw than this, but they both show light coming from the light bulb to my eye. Now let's use the ray diagram to describe what is happening when light from a light bulb hits a mirror and reflects the mirror, and I see the light from the light bulb. So yes, light is going off in all directions, but the only part of the light that I care about is the ray that goes from the light to the mirror and then reflects off the mirror and goes to my eye. So there's a very simple ray diagram of light from a light bulb reflecting off a mirror and coming to my eyeball for me to see it. This could be anything. This could be anything that light is reflecting off of. You look into the mirror and you see its reflection. That's what's happening. The light is reflecting off the mirror and coming to your eye. What if the mirror is... and you are standing over here, and you want to look at your feet in the mirror. Well, I know light from my feet goes everywhere. It goes up here. Well, first of all, the sun is shining down, hits my foot, and reflects off my foot. And if you were standing over here, you would see my foot. If you were standing over here, you would see my foot. No matter where you stand, anywhere near me, you would see my foot because light is striking my foot and traveling off in all directions. But all I care about is the light that comes into my eye. So I am going to draw the ray, the light my foot, and hits the mirror, reflects off the mirror, and goes to my eye. All right? The law of reflection says that the angle of incidence, I look at that ray coming in from the light bulb and I compare it to the normal. The normal is an imaginary line that is perpendicular to the surface of the reflector, in this case the mirror. And that angle between the ray and perpendicular, or the normal, is called the angle of incidence. And the law of reflection says that that will be the same as the angle of reflection. So we have theta I equals theta R. That is the law of reflection. Sorry, there we go. Theta I equals theta R. That is the law of reflection. So I can apply this down here, and I can draw the normal at the place where the light is striking the mirror. And here's the light from my foot making an angle with the normal. So that is my incident angle right there. Theta I for incident. Reflects with the same angle according to the law of reflection. And I can see my foot in the mirror, which means all this part of the mirror down here, I don't need it. I can see my whole body from my head to my foot in a mirror that only goes down to half my height, okay? And of course, to see the top of my head, that light goes from the top of my head, reflects off the mirror, obeys the law of reflection, and comes to my eye. So really, I don't need this part of the mirror either. And I can see my whole body in a mirror that's basically 1/2 as tall as I am.